Welcome everyone to your first Milestone project. You now know enough to actually create a real program. And so since this is your first Milestone project, we're going to create a tic-tac-toe game for 2 human players. Let's describe what the game will be like and what approach you should take when tackling on your first Milestone project. First off, the basic idea of the game is that 2 players should be able to play the game both sitting at the same computer. And the board is going to be printed out every time a player makes a move. You should be able to accept input of the player position and then place a symbol on the board. So we have these kind of larger problems, and what you should do when you're thinking about this Milestone project is try to break these down into smaller sub-problems. And that idea of breaking down the larger problems into smaller sub-problems is why we created a workbook, Jupyter Notebook for you that you can kind of go through and create functions in step-by-step fashion. Now let's describe the actual idea here of putting keyboard input and converting that into something that corresponds to a tic-tac-toe board. We're going to be using the idea of a number pad. So if you have a larger keyboard, often it has a number pad to the right of it, and we're going to match those numbers to the grid on a tic-tac-toe board. And it's up to you which way you want your number pad to go. On a keyboard, it looks like this: 1, 2, 3 at the bottom, 7, 8, 9 at the top. But often on an older phone model, when you deal with the number pad, it goes the opposite way. It has 1, 2, 3 on top, 7, 8, 9 on bottom. Again, totally up to you. The main idea here, though, is that in our mind, we're going to have a tic-tac-toe board over this number pad, and then a user, they're going to, using the input function, it's going to ask them, hey, where would you like to place your X or O? And then they'll provide a number that corresponds to the tic-tac-toe board, and what we're going to do is then print out the tic-tac-toe board with an X at that location. And then the next user is going to choose their number, such as 8, and that will put the next symbol, O, there. So we're going to alternate between X and O, ask the user for the input number, and then place that symbol on the board. And then later on, we'll check to see if someone has won or if there is a tie. Now, since creating your first full program is always a big leap forward, you're going to come out the other end a much better programmer. But since this is such a challenge, we've set up a walkthrough notebook to help guide you along with the functions that you're going to need to create. So let's explore what the game's actually going to look like once it's done. And then once we've done that, we're going to cover a few useful functions and go through the walkthrough notebook and show you just a couple of things to help get you started. Okay, let's jump over to the actual notebook that has the solutions. I'm not going to show you the solutions right now. I'm just going to show you what the game looks like when you run it. Okay, here I am at the solution notebook. I'm pretty zoomed in, so we only see a few lines of the solution code, but there's a lot more code through this, but I just want to show you what this actually looks like and an idea of what the game should look like when you run it. It doesn't have to look exactly like this, but this is the main idea. First, we ask the first player, hey, do you want to be X or O? So using the input function, we can pass in a string, X, hit enter, and then it'll say, hey, player 1's going to go first. Are you ready to play? Enter yes or no. So then we enter yes, and then you can imagine that that's starting some sort of while loop to continue playing the game. And then we have choose your next position, and notice here we've been able to print out a board. And these are basically just print functions with kind of larger strings. And in the middle of some of these are going to be curly braces. You can't see them right now because they're empty, but they're curly braces that correspond to the index position of some list. And then when the player, using the input function, asks for the next position, let's put in 1. We can see here that we automatically draw an X at that 1 location. And then the next player says, hey, choose your next position. Let's have them choose 8 like we did in the slides. They hit enter, and now we have O there. And then we choose the next position, and so on until someone's won. So I can say 2 here, and we'll have, let's say 9 for O, and let's make X win by putting in 3. So here we have 3 in a row, tic-tac-toe has been won, and it says, congratulations, you have won the game. And then we ask the player, hey, do you want to play again? Enter yes or no, and let's enter no. Hit enter, and that breaks this cell. So you can see here, there's a little hint here, if not replay. So we can see here, replay some sort of function that was accepting yes or no there. All right, so that's the basics of what it should look like. Let's now hop over to the workbook notebook, explain what that looks like in order to get you comfortable with the idea of lining up these functions. And then we're going to show you a couple of useful things in case you want a little head start on the solutions. All right, so the actual notebooks, if you go to Complete Python 3 Bootcamp, either you've downloaded this or you're at the repo, come over to Milestone Project and you'll see a couple of useful notebooks. One is the assignment notebook. This assignment notebook is just a description of what it is you need to do. It's basically the notebook that corresponds to the lecture right now that you're viewing. And it looks like this. It just says congratulations and a couple of bits of information. The notebook that you're mainly going to be working with is this walkthrough steps workbook. And this notebook looks like this. So this is the walkthrough steps workbook, and this is something we designed to help you guide you through the functions that you're going to need to create. It has some suggested tools, such as the input function that you've seen before, and then it also notes that if you want the input to be an integer, it may be a good idea to cast it to an integer using int. Then we also have some information about how to clear the screen between moves. This is a special Jupyter Notebook function. There's also kind of a simpler way to clear the screen, which is just to print 100 new lines, and then you can scroll up to view the previous boards. All right, so what does this actually look like as far as a workbook notebook? Well, we've divided up the entire project into steps, which have placeholder functions for you to fill out, and then we have tests for each of those steps. And you can see here step 2, test step 2, step 3, and eventually you go along, and at the very end, there's going to be less tests because you won't really need them. And finally, there'll be kind of some ideas of how you should set up the logic for the game. So what does these functions actually look like? Well, for instance, the very first function wants you to write a function that can print out a board. So you set up your board as a list where each index 1 through 9 corresponds with a number on the number pad, so you get a 3x3 board representation. So what this is expecting to happen is when you pass in a board list into this display board function, you actually print out that board. That way, later on in your code, you can actually call this function and it will continually print out the board whenever you want it. So in order to test this function, we have test step 1, where we've created a test board for you, some board that's already full, and then you can say display board. Then the next one is to write a function that takes in player input and assign their marker as X or O. Think about using while loops, and we continue along with these cells. All right, so that's the basics of the workbook. Now, since this is such a big project and it's going to be kind of a big leap forward, what I would recommend you do is if you ever feel uncomfortable, jump to the solutions and treat it as a code along lecture. And then once you're done coding along with that, see if you can come back and independently fill out some of these functions on your own. And that will really help you connect the dots of dividing this problem into smaller subproblems. Okay, so that's the main idea of the Milestone project. If you want, right now you can just stop this lecture, go ahead and jump to it. And you can also just open up a script or open up an empty Jupyter Notebook file and see if you can do this all on your own without the workbook. What I'm going to do now is give you a little bit of a head start because I know it can seem very daunting. I know a lot of students, they look at this step 1 and they just get totally stuck. There's kind of this roadblock in their mind of where to actually begin. So I think it's really helpful if you're completely stuck on the idea of how do I even approach this task. I'm going to show you a way you could display the board, and then I'll show you a little bit of step 2 and a little bit of step 3. So these are just hints. It's not the full solution walkthrough. It's just something to help get you started. I'm going to open up this workbook in a Jupyter Notebook and continue on. If you don't want any hints on how to get started, go ahead and just stop the lecture here. Okay, let's go to the Jupyter Notebook. Okay, here I am at the walkthrough steps workbook. I'm going to work through the couple of first steps just to give you a little help pushing you forward through this project. Again, if you want to tackle this on your own to start off with, you can stop watching the lecture. First thing we're going to do is discuss actually printing out the board. So as we mentioned, we kind of want you to set up the board as a list that looks like this. And at first, that test board list or the board list is going to be empty, and we're going to use user input to index this list and then assign it the actual string value. So how do we actually display this board if it's a list? Well, we could just use a bunch of print functions. And I'm going to do a very simple version of the board here, where I'm going to say print, let's say the board at index 1 plus, as a string, some pipe operator, and then the board object at index 2 plus some pipe operator, or any symbol you want really, and then concatenated with board at index 3. And then we're going to copy this and fill out the rest. So we'll say this and this. So 1, 2, 3 is at the bottom. Again, you can kind of reverse that if you want. And we'll have 4, 5, 6 here. And then 9, 8, and 7. And let's run this and see what happens. Whoops, I have invalid syntax. I forgot the plus sign here. Plus, plus, plus. Okay, now when I run this, what I'm doing here is I'm going to print out whatever string is at board 7, a pipe operator, then whatever string is at board 8, another pipe operator, and then board 9. This is not going to look as nice as the tic-tac-toe board I just showed you, but it should work to some degree. So I rerun this, and let's display the board. So I'm going to pass in this list. I run this, and here's my board, XXX000, or 000. And that's the basic idea of displaying the board. And then later on, you can get a little fancier. If you want those horizontal lines, all you need to do is just print out a couple of dashes that maybe look like this. That's probably way too many. Let's just do something like that. And now when I rerun this, you can see how that's slowly starting to kind of affect the board there. And maybe you want uppercase dashes yourself. So maybe you want something like these pipe operators here, start lining them up, and you can start to get really clever with the way this is going to look. So that's the basic idea of just displaying the board. We've taken the board itself as a list, grab the index positions, and then we will print out whatever value is there. Now keep in mind your test board at the very start of the game is going to be probably a bunch of empty strings. So it's probably realistically going to look something like this. We'll say just times 10 here. It's going to look like some sort of empty board. So if I rerun this, it'll look like that. So that's how the board starts off, and then as people start actually putting in X's and O's, it will clean up the board. Now, if you keep calling display board multiple times, you'll be able to see a history of the board. If you don't want that, what you could do is clear the output from the previous board. So later on, you can experiment with running this clear output line, or if you're running a Python script, running this line right here, which kind of prints out 100 new lines. And what this does is because later on during your logic, if you keep asking to display the board, it will show you an entire history of all the print functions or print statements you used to do. What you could do instead is clear the output and then only show the board itself. That way it actually appears to the user that the board is being updated instead of printing out a new version of the board. So you can play around with this to get an idea of what I'm talking about, and you should be doing this before you actually print out the new version of the board. So that's how you could display the board. And I'll give you a couple more hints about step 2. Okay, the next thing we want to do is write a function that can take in a player input and assign their marker as X or O. And we want you to think about using while loops to continually ask until you get a correct answer. And there are a ton of ways you could do this, but I'm going to show you just a quick example way so you can hopefully get the mindset ready. One way is to set your marker as an empty string. And then what we're going to do is keep asking one of the players, such as player 1, to choose X or O. And then once they've chosen, we'll assign player 2 the opposite marker. So how can we keep asking player 1 to choose X or O? Well, we can say while the marker is not equal to X and the marker is not equal to O. So that means the marker is both not equal to X and not equal to O, meaning someone hasn't supplied the correct input. What I'm going to do is set marker equal to the input player 1, choose X or O. That way if the player accidentally puts in a number or puts in another letter, it just asks them for the input again. And then once we have that input, what I could do is say player 1 is going to be equal to that marker, and then we'll have a little if statement here for player 2. We'll say if player 1 is equal to X, player 2 will set that equal to O. Else, player 2 is then equal to X because we know player 1 chose O. And finally, what I could do in order to return both player 1 status and player 2 status for their markers, I can return this either as a list or a tuple. That way I can use tuple unpacking later on. So I can say return player 1, player 2. So let's run this and make sure it works. So I'm going to call player input function here, run that, and it says player 1 choose X or O. So let's give it a wrong answer and see what happens. Okay, let's give it a number, see what happens. So it keeps asking us, hey, choose X or O. So if we choose an X, then it reports back, okay, X and O. So player 1 is now X and player 2 is now O. And the way you can work with this is actually assign them to a tuple. So what you could do is say tuple unpacking in the following form. create player 1 marker variable, comma, player 2 marker variable, and set that equal to the output of player input. That way, when you run this, and you actually choose a value, O, you can then say, hey, what was player 1's marker later on in your code? And it'll tell you it was O. And if you ask for player's 2 marker, it was X. Okay, so those are a couple things to help you get started. In the next lecture, we're going to go over all the formal solutions, and we'll see you there. Best of luck on your first Milestone project. If you ever get stuck or have any questions, feel free to post to the Q&A forums. We'll see you there.